Now that the bell rang, that was unplanned, but that worked also. We are going to look at the practice problems from section 6.3. You will need basically two things. The first one is within your outline packet. You should see this page right here, structural pair geometries of 2 to 4 structural pairs. And yours is going to be white. Anytime you use it at the computers during a quiz or during a test, it will most likely be on this purple paper. So you need to have this diagram out with your paper to do the practice problems. And then the second thing that you need are Lewis structures. So when we look at the practice problems, the first one was CO2. I've already drawn the correct Lewis structure. You can look back at previous problems and you can see that that's what that structure came out to be. So now what we need to do is look at the central atom only. So we're going to look at the central atom. I suggest as beginners to this process that you circle the central atom and any bonds that are associated with it or any unbonded pairs. So as I'm looking at carbon, the central atom, I see it has one double bond here and one double bond here. That counts as 2 bonds. I also see that on the carbon there are 0 unbonded pairs. I simply add that together. 2 plus 0 gives me 2 structural pairs. So now I go to my shapes page. I look at the fact that from the Lewis structure, we see that there are 2 structural pairs. So I use my diagram and I look at the left side, number of structural pairs, 2. That tells me that based on 2 structural pairs, this is a linear shape. So this equals linear. I also look at the fact that it's 2 bonds and 0 unbonded pairs. So 2 bonded pairs and 0 lone pairs. You might want to write on lone pairs that means unbonded pairs. So now our secondary answer is that it is also linear. The molecular shape is linear. So based on this information, we can see that this shape is linear. Example number 2. We have methane, CH4. So again, we're going to start with the idea that we circle the central atom and any bonds or unbonded pairs associated with it. So I see 1, 2, 3, 4 single bonds. So I say I have 4 bonds. There are no unbonded pairs, so I have 0 unbonded. Adding those together tells me that I have 4 structural pairs. I go back to my reference page. I look down the left side until I find 4 structural pairs. That tells me that the structural pair geometry is tetrahedral. So 4 structural pairs equals tetrahedral. And as I look at the structure of those pairs, 4 bonds and 0 unbonded, I continue across, I see 4 bonds, 0 unbonded, and that still tells me that this is tetrahedral. You must remember that you have to give me 2 answers. Every time I ask for a shape of a molecule, you must give me 2 answers. When I ask you to write out work for me, I suggest that you draw your Lewis structure, circle your central atom. Then list the bonds, the unbonded, give me your total of structural pairs, and then what each of those geometries work toward. Example number 3 is ammonia, NH3. We're going to circle that central atom again. Based on what I see in the central atom, I see 1, 2, 3 bonds. So 3 bonds. And I have an unbonded pair. So 1 unbonded. 3 plus 1 gives me 4 structural pairs. I look back at my reference page. 4 structural pairs tells me that it is tetrahedral. And then if I continue with the 3 bonds and the 1 unbonded, 3 and 1 tells me that that is going to be pyramidal in shape. Again, look at the 4, come down to 3 and 1, and I see that it is pyramidal in shape. So my 2 answers, tetrahedral and pyramidal. Our last example is water. I'm looking at the central atom, so I circle the central atom and anything that is bonded to it. I see 2 bonds, 1, 2. I see 2 unbonded, 1, 2. Adding those together, I get a total of 4 structural pairs. I go back to my reference page. On my reference page, 4 structural pairs tells me it is tetrahedral. Going back to our bonds and unbonded, we have 2 and 2. 2 bonds, 2 unbonded. That tells us that the shape is bent or even V-shaped. So we're just going to use bent as our answer. At the Chem 2 level, you're going to use the back side of this page, which has 5 and 6 structural pairs, and then you would need to tell me that it is specifically V-shaped and what the angles are. But that's for Chem 2, not for this class. This concludes our practice.